Good morning, everyone. This is Ryan Miller with North Carolina Building Performance Association, welcoming you to today's webinar. It's November 19th, 2019, 10 a.m. Eastern Time, and we are recording this live from Raleigh, North Carolina, and we will have folks listening in later on via our recording, and welcome everybody to the webinar. I'll provide a little bit of an introduction here and then kick it over to Scott Kind with Spirit Sales Group. Scott and Spirit are a member company of NCBPA, and we welcome them and thank them for putting on today's webinar. You'll be hearing from Scott on continuous insulation, speaking to the energy efficiency and performance benefits of various types of continuous insulation materials. So this is kind of continuing the series of webinars we've been doing for the last couple of months on building envelope and insulation products. I think we've had I believe the third webinar in this series, and our member companies have access to all of those webinar recordings via our website. So if you're not already a member of NCBPA, we would love to have you in the association as a member company. Dues start at $300 per year and go up to about $600 per year based on the number of employees that you have. And our association represents companies all over North Carolina, and actually all over the country as well. So just a little bit of logistics before we jump in here. We will be keeping folks on mute for the duration of the webinar. That is just to avoid background noise, barking dogs and cars and things like that. So if you do have a question or a comment, please feel free to put that into the chat box. And GoToMeeting, we will be stopping every 10 minutes at least to see if there's any questions or comments, and we definitely encourage those from folks here in the audience. If you do have any additional questions, we will be opening up the line at the end, and we can have a little bit of discussion there via the phone. So make sure that you're connected to the audio, and if you have any questions with that, please do put in a message in the chat box and ask. If that doesn't work for you for some reason, feel free to shoot me an email, and you've got my email address on the screen right now. So before I push it over to Scott for the webinar, wanted to speak to just a couple of items from the NCBPA perspective. This webinar, as I mentioned, is part of the series we've been doing on building envelope and insulation. Generally speaking, we do webinars at least once a month, sometimes twice a month, and we have lots of plans for that for next year in 2020. So if you're interested, let us know. We've recently started a new partnership with PIMA, the Polyiso Cyanurate Insulation Manufacturers Association. We're working with them to do a couple things on building code education, some different regulations and policies, and just general education in our industry. And we know that Scott and some of the folks that he works with are members of PIMA and actively working with that association. So we thank PIMA for their participation with us. They will be actually having a track with us at our conference next year. Additionally, we've got a couple of positions open on our board of directors. So if you are someone who likes to provide a little bit of volunteer service to your industry, we would encourage you to consider joining the volunteer board at NCBPA. We've got information up on our website, either under the About and then Board of Directors page, or if you go to our news page, we have a post there. There's an application on our website, pretty simple and short, and we're definitely looking for industry leaders and veterans and emerging professionals and folks that have a little bit of time, generally about 4 to 6 hours per month, to help our association and industry grow in 2020. So please do consider if you're interested. We're also helping a member company sell their business. So if you are interested in running your own home performance business that's based in the Triangle, we have one for you. That is a service that NCBPA provides to our members and our industry, is to just help connect folks for new and exciting business opportunities, and that happens to be one. So you can find some information about that on our news page as well. This week, and actually starting last week, we've had a 3-part article series via email. Last week, we were talking about workforce development opportunities in the state. That is to create the career and job resources that our industry needs in order to be successful. We've been doing an awful lot of work on workforce development over the last 3 years, speaking to students, working with faculty members, and in February, we're planning to hold a second Workforce Development Summit, where we'll bring together about 100 people, faculty, students, local government, industry professionals, to talk about workforce opportunities and needs. Yesterday, We sent out a similar email with the topic of policy development. It included our legislative plans for 2020, so even if you are not a policy wonk, we would like to make sure that folks in our industry understand what those big opportunities are and offer support when able. And then in a couple of days, we'll have our last email in the series coming out on market development. That will just target some different opportunities across the state that we can do to improve our market, reduce barriers, things like that. And those 3 items we have estimated will add about $20 billion of new revenue to our industry over the next 5 to 10 years. There's quite a bit of math behind that, and we do have a report on our website, our Energy Efficiency Potential Report, that speaks to that in more detail. And then lastly, part of our mission this year has been to improve and communicate and inform on the role of energy efficiency and the clean energy environment here in North Carolina. You can also find some information and articles on our website that speak to the role of buildings in this environment. So our preference with sort of the same tagline of reduce, reuse, recycle is to reduce energy usage in buildings first, then reuse energy provided by clean sources like renewable energy, of course, and then lastly, recycling available energy in buildings and vehicles. That is the strategy that we at NCBPA take, and a lot of our members work along those lines as well. So just a little bit of information about NCBPA and what we've been up to lately. We've got lots of plans for 2020. And as I said at the top, we would love to have any companies out there that are not members of ours to join the association. 12 months, $300, which is about $25 per month minimum. And then we will be happy to help your business and appreciate your support. So without further ado, I'm going to go ahead and kick it over to Scott Kine. So we will be recording today's webinar. So if you have any questions, if you miss anything, just know that you'll be getting a recording of it soon after. And then also we'll be taking questions via the chat box as well. So if you have anything, just let us know. And Scott, without further ado, show is yours.
Thank you so much, Ryan. And that was actually a great segue when we start talking about energy efficiency in buildings. It's really what we're going to be talking about here today. Also wanted to mention to everybody either watching the recording or listening today, please look into Ryan's organization and the work that they do. I would highly recommend becoming a member. They actually just perform a lot of real world change in a lot of different ways. So highly recommend becoming a member of the organization. First, I'd like to start off by just sharing a little bit about Spirit Sales Group. We are a building envelope rep firm functioning in the Carolinas and Southern Virginia. Please visit our website or follow our LinkedIn page or YouTube page. On the manufacturers on the left of our line card are all those that we represent either in Virginia or the Carolinas. So today we get the pleasure of talking about continuous installation, energy efficiency, and performance comparison of CI. So of course, just so everybody understands, CI is the buzzword abbreviation for continuous installation. What we want to do today is kind of look at the big picture and the overall products of what product might fit best for you. And so some of the key takeaways that I want you to be thinking about are insulation materials. I'm going to share with you how they've evolved over time. And then from a sustainability standpoint, what are the real attributes of all these different types of CI products? Then the other thing that you really need to think about, whether you're an installer, general contractor, or an architect or an owner, installation of each product, because that has a huge impact on long-term performance, but also cost. So I want you to pay attention to installation. We're going to do some comparison of the different types. And then from a design standpoint, again, talking about installation, the wall cavity has changed so much the past 10 years. How do we keep it simple when we're dealing with an industry that is sometimes slow to change? And you got to remember, at the end of the day, We have folks in the field that have been doing it one certain way for 30, 40 years, and their world has really changed the last 10 years. So how can we keep it simple from a design standpoint to set them up to win? So those are the things I want you to kind of pay attention to. First, talk a little bit about Hunter Panels. So the company that we represent is Hunter Panels. On the wall side of the business is called Hunter XCI. They have a roofing side of the business, which we do not represent. We work with that group, Premier Building Products. But on the wall side, it's called Hunter XCI. And who is Hunter? It's a company that founded in 1997, and their primary focus is only on Polyiso. So that's all they do, and they do it very, very well. And why would you? There's several Polyiso manufacturers out there. What sets Hunter apart would be they are not just an industry leader, but a global leader in ISO manufacturing. They are owned by Carlisle Construction Materials. So when you select an insulation that you put on your building, you have a company that has your back, and Carlisle Construction Materials is a multi-billion-dollar company. And then they've been focused on the CI market for some time now, and definitely would consider them a leader. So that's a little bit about Hunter. And then the other kind of key attributes, when you start looking at your insulation manufacturers, as CI grows, demand grows, does your plant or your manufacturer have the capacity to keep up with that demand? We often hear where lead times, as demand grows, lead times grow, and that has a huge impact if you can't get material within a short amount of time. So Hunter has a huge advantage of having 7 plants around the country. Here in North Carolina, we will pull from several different plants as needed. Lake City, Florida, the Pennsylvania location, sometimes the New York, and sometimes Texas. So CI, let's just take a second to really kind of think about this. What is our value? How do we get to where we're at here? So remember, a key thing that I was involved with last year was we did workshops on the new energy code in North Carolina that Ryan and NCBPA put on. And in that workshop, we talked about the new changes to the energy code, where in North Carolina, now part of the code is the effective R value. So that means if you put a piece of insulation in there that is R20, how does it actually perform in the wall cavity? And that's now how the code looks at it and measures it. So our effective R value, when we put all of our insulation between the metal studs, is not very much. And that's because a metal stud particularly conducts so much thermal loss back and forth that the insulation in between the studs is really not doing what it's supposed to do. That's what's kind of generated and led to CI being part of that. And this picture just does a great job of really kind of illustrating why CI is needed. But before we do that, we kind of have to look back at how did we get to where we're at. Way back when, our structures were more smaller, and the way we insulated it was by mass. So we just built thick, heavy walls, if possible, a thick, heavy roof, very little openings, very few doors and windows, because we knew that was a point of heat loss, right? Well, obviously, things have changed. Our buildings have evolved. We've switched to now wood or stone products. We could use thicker products like brick back in the early part of the 1900s. So nowadays, most of our buildings are driven and built by, a lot of concrete, but also the evolution to steel and thinner products. So, we look at, a steel mass structure or metal stud walls, and that's typically how we built. That's especially the last 12, 15 years, there's been a huge flip to that type of construction. And while those types of buildings look great, from a thermal efficiency standpoint, they don't perform that well. there's some information on the recent Google building in California, where they are touting how efficient this is, how helpful that building or campus is into the environment. But the actual effective R value of that wall assembly is a 2 or 3. So we're going to show you how to properly do that here today and make your buildings just perform much better. Again, American ingenuity, or the human ingenuity, back in the early days, we did whatever it took to kind of make insulation because it was just needed. And then in the early 1900s, in America, it was basically fibrous materials were used. And these were the most common: mineral fiber, glass fiber, cellulose fiber, asbestos. Remember, we're putting this in between our studs, and it's just kind of what was the norm. So with any product, let's look at the pros and cons. So those type of products, the R value is derived by air pockets within those fibers. So you needed a thicker insulation to get a higher R value, so that you had more little spaces in between that insulation. Now, of course, the challenge with that is if that insulation becomes compressed, it's less effective than what it's designed to do. A big advantage of it is from a fire performance. They typically did very well. A challenge with those products is they don't do so well when it comes to moisture, water, or air movement throughout. And I'm going to get into that here in a little bit. Now remember, if you're measuring R value based on those little air pockets, if you add moisture, water, or air through there, then your effective R value is going to be impacted. So I'm proud to say that I don't remember these days, but I often heard of it. So as born in the early 70s, this was well known when I became a kid, the oil embargo from overseas into America. And what that did is, you may have heard stories about long gas lines and waiting for, half a day or a day just to get gas. And that was because America was so dependent upon foreign oil. And of course, we're kind of in that same situation today, and our goal is to keep coming up with different ways to not be in that position. I tell you this because in the early 70s, that led to a new type of insulation to be used and be more prominent in the marketplace, and that would be foam plastics. So look at who consumes the most oil. This slide always just kind of hits home with me. In America, we consume, the slide's about 3 or 4 years old, but in America, we consume about 26% of the world's oil production. The next closest is Japan and China at 6 and 7%. So this just really kind of hits home to me that in America, we really, really are energy hogs. Kind of is what it is. And then when we start looking at America's energy consumption, we typically break this down by 3 separate sectors: industry, be our factories and manufacturing, transportation, and then buildings. And this slide's about 3 or 4 years old, and some of the recent data that I've heard is the buildings are as high as 46%, almost half of US energy consumption. So if that is the case, then we really, if we don't want to be dependent upon foreign oil, we really need to look at 2 things. What are we putting into our buildings that can make them perform much more efficiently? And then also, what is the cost of getting that material into our building? How does that impact these other 2 industries right here? How does it impact the industry sector and transportation sector? And we're going to take a quick look at that. Hey, Ryan, do you want to take a break? Is there any questions in the chat box?
Yep, thanks for the prompt there. Let's check the chat box real quick and just see if there's any questions. So I don't see any yet. So just as a reminder for folks, if you do have questions or comments, please do put those in the chat box, and we'll take a break here every couple minutes and take a look and see what you guys have to say. So Scott, I don't see any right now, so we'll turn it back over to you.
Absolutely. Oh. Let's see here. I lost control, Ryan.
All right, try it again.
Okay, there we go. So, so as we evolved, what had happened is not only the market, but the government had said we have to kind of improve our buildings. 2006 was the first edition of a CI requirement as part of the building code. And most building scientists now recommend that our control layer, which is our WRB air barrier layer, and our thermal management, our insulation, should all be on the exterior side of the framing when possible. And I bring this up because basically now, fast forward 2019, almost every state or jurisdiction in America has adopted some form of a building code, whether it's ASHRAE or IECC or their local energy code that requires CI. There's maybe parts of a few states here and there that don't require it, but in North Carolina, it is part of the code, and basically that's the law. So this is everywhere. This is not going away. So the common types of products that get used in this application, you know, we have to meet CI. How can we do that? What's the best way? So one of the first things that we typically look at is R value. Now there's products have different performance attributes, and we're going to go over all of those. There's typically never a one size fits all, but let's just look at first and foremost the R value. So basically, Polyiso is going to range about 6 to 6.5 per inch. And I will say this too, ISO is, the R value is going to expand exponentially the thicker it gets. What I mean by that is the R value for 2 inches is going to be more than double the R value of 1 inch. Spray foam polyurethane, that's going to be dependent upon whether we have an open cell or closed cell product, but you can see where the R value, how that can vary. Polystyrenes are typically going to be about 5. So the difference between the two polystyrene products is just in the manufacturing. One is extruded, and it gets manufactured or pressed, and the other one is expanded, where the polystyrene just kind of does that, expands and cut into a board. The other thing that will affect the R value of those products is the density. So they're going to get measured essentially the same way, but they communicate the density in a different way. Extruded polystyrene, your blue boards and pink boards, they're going to get measured by PSI. So it's going to be 20, 40, 60, 80, 100 PSI, where expanded polystyrene, the density get measured in pounds. So 1 pound, pound and a half, 2 pound, 3 pound product. And then our R value for mineral wool is going to be about 4, and fiberglass is going to be about the same. So when we look at foam insulation, particularly some of the benefits of that and how some of the attributes of how they determine R value is basically during the manufacturing process, a blowing agent gets combined with gas and forms a cell. And that's going to determine the R value. So some of the advantages are you have a higher R value per inch and thinner profiles. The fire performance capabilities of the foam products can vary greatly. And I want to take a second to talk about that. In the commercial roofing industry, Polyiso probably has about 90% of the market. Go back 25, 30 years ago, that was particularly not the case. It was more of the polystyrenes. In the walls right now, I would say Polyiso has less than 10%, but growing, where extruded polystyrene is now shrinking. And the reason is what happened in roofing the past 30 years is what's happening in walls. And it all has to do with fire. So in roofing, basically, there was a fire at a General Motors plant that it was a small fire that was contained, but because polystyrenes have such a low softening point of 160 degrees and a low melting point of 210 degrees, when it heated up to 210 degrees, that insulation that was on the roof deck of that General Motors plant literally melted and added fuel to the fire. So that entire plant burned to the ground, and the insurance industry said, we'll never allow extruded polystyrene directly over a metal deck because we don't want to do this again. That's typically what insurance companies do, right? They pay out a claim and they say, hey, let's not do that again. So as the wall industry has evolved, part of the requirements is fire test, and we'll get into that in a second. And as I mentioned, the polyisos are going to perform much, much better than the polystyrenes. Okay, and so those are the different types there on the right: the ISO, the polystyrenes, the XPS and EPS. EPS is going to be expanded. That'll be your styrofoam coolers, coffee cups, that kind of stuff, and then spray foam. And then installing the products. This is typically what they're going to look like in the field. You see the one on the left is a foam insulation product. The one on the right is going to be a fibrous insulation put in between steel Z's. And there's tons of different ways to install these, and we're going to talk briefly about that. So again, I talked about ISO. Polyiso manufacturing, there's lots of plants around the country. Most of them have been using newer technologies, newer blowing agents, and should have been made within the last 15, 20 years. And it's typically they're putting out this foam, and there's a chemical reaction, and the foam will expand, and it gets sandwiched together between two facers. In contrast, a mineral wool product is going to be manufactured a little differently. You know, I'm from Northeast Ohio, where the steel industry was huge, and all around our small little town where we had a steel mill, there was tons of slag that was a byproduct of the steel mills. So in order to make mineral wool, part of the process is to melting steel mill slag and rocks at a very high temperature, and they spin it real fast to create a fibrous material. And then in the end result, they come up with some type of board or bat material, depending on the density. And again, as we mentioned, the R values are calculated based on air in between those fibers. So I think going back, looking at how those products are made, you kind of have a small, quick snapshot of polyiso and fibrous materials. Again, we look at overall big picture energy consumption than performance. Much more energy is used to make those fibrous materials than polyiso. The foam is a much faster, efficient product. And the way that you can measure this is pretty easy. What the industry typically does now is look at EPDs. So all manufacturers can publish these, and there's all different benchmarks based on the type of material that you're selecting. So EPDs are environmental product declarations. And what they do is they typically look at these 5 factors and how we make the product, how does it impact the atmosphere based on these 3 factors on the left, and how does it impact our water based on these 2 factors on the right. So I'm not going to get way down in the weeds on each factor, but we can talk about that later. That's part of other presentations. But it's definitely important because this, again, reiterates how do we get the insulation to the job and how does it really impact the overall environment. Just one example of how this works. If you look basically right here, you can see that the polyiso, mineral wool, and spray foam, when it comes to ozone depletion potential, are all pretty level, right? They're all pretty consistent. But the XPS manufacturers are way out of whack. The reason for that is they have not traditionally kept up with more higher performing and more energy friendly blowing agents. So that's typically why they have that rating. And this is just one of the 5 examples. So again, looking at both our foam products that we've discussed and fibrous boards, similarities and differences, they're all used for CI. The same trades are installed in these products. They're both used in an NFPA 285 compliant wall assembly. So remember, that's the fire test that I was talking about. And that is a test that looks at the entire assembly. I always tell folks, think of it as a sandwich. You know, if you have a big sandwich, you have bread, meat, lettuce, cheese, lots of different components. Same thing with our wall assembly. So when we test to be NFPA 285 compliant, we're looking at all those different components. The differences are going to be material weight and size, how we potentially attach the insulation, and then both water and air management. Hey, Ron, do you want to check the chat box real quick?
I do. Thanks again for the prompt there, and you're doing great, Scott. Very helpful information. I again do not see any questions or comments in the chat box, so I assume, Scott, that you are doing a tremendous job. So I'll kick it right back over to you. And again, if folks do have questions, then please do put them in the chat box and we'll take care of those.
Gotcha, thanks. Okay. Okay. So traditionally, how we used to install these products was with the steel Z or a metal Z. And I'm going to show you in a second. Remember, we saw that slide earlier, how we saw how much thermal loss or energy was conducted back and forth with that steel Z. So in North Carolina, our new energy code, we don't allow this. And most of the energy codes across America, we don't allow steel Zs anymore. The way a CI requirement is only through service openings and fasteners. And here's why. So in this example, this is a test done by some consultants. And again, in North Carolina, the code mandates we measure effective R value. We take an R10 insulation and we install that, putting steel Zs together. What is our new effective R value out in the field? So if we were doing this in person, I would put somebody on the spot, but that's not the case here today. So the drum roll is the effective R value is now R4. So if you're an owner and you've paid for R10 and your effective R value is R4, that's obviously not what you paid for. If you're a designer and you've designed it based on R10 insulation so that the rest of the building can function and perform as you designed, your effective R value is not nearly where it needs to be. So what can you do about it? Well, we can look at doing cross members or some kind of other system to install this insulation. It's possible, becomes a little bit more labor intensive and costly for the framing, but our effective R value is still not where it needs to be. We lose 20% by just doing this. So in our industry, what has evolved on the commercial side, and even high-end residential, is how do we attach our cladding and our insulation? There's all different types of clips and brackets, racking systems, as you see on the right. As you can imagine, this becomes very cumbersome, very labor intensive, and very expensive. I remember what I talked about at the beginning. We want to try to keep it simple. We're asking guys in the field to put this together that have been doing it one way a long amount of time. So those same guys, you have to kind of look at what is it going to take for them to install a product. So what we did here is we just did a little comparison of a fibrous product, mineral fiber board, and a Polyiso board. And so we did a direct comparison of R13. The size of the board are both 4 foot by 8 foot wide. The ISO product is 2 inches thick, The mineral fiber product is 3, so that we have the same effective R value. And then we want to look at the comparison of the weights between the two. And we want to look at the cost to install it. What's the real cost to install it? What is the real cost to handle it? What are design requirements? And I think this slide just kind of hits home for me, because would it be easier to lift one 10-pound dumbbell, or would it be to lift 4? Well, that's pretty obvious, right? But a better way of looking at it is a side-by-side work study. Excuse me. So basically, we've seen this in other lines that we represent, whether it's an air barrier. Hey, let's look at this side by side. Let's have the guys in the field try to put this together like they're trained and equipped to do, and then let's measure it. So what we did here is we took a building that was 35,000 square feet, R13, and we kind of said, hey, go put the insulation on. So over on the left, you have a 3-inch, 2-foot by 4-foot dual density mineral fiber board, giving you an R of 12.9. On the right, you have 2-inch R13, same size, or a 4x8 board. So what I want you to pay attention to is the packaging and how many square feet are on a truck, and then how many trucks are required for this project. Not a huge project. It's going to require 2.5 trucks of mineral fiber products to service the job. The ISO is going to be less than 2 trucks. But more importantly, look at the pieces. Because mineral fiber products come in smaller sizes, thicker to get R value, smaller sizes to handle, they're going to handle almost 4,400 pieces of insulation compared to ISO, which is going to be less than 1,100. So mineral fiber, it's going to be 4 times the amount of pieces to install. So when you kind of think about that, you think that has an impact on labor. You think that has an impact on the size of the wall cavity, because that all measures fastener length and performance of your wall. How about from a scheduling standpoint? Do you think a general contractor would prefer a product that has 1/4 of the material to handle? How about from storing it on site? So those are the things I want you to start think about. Not just one performance characteristic. You have to keep the big picture in mind. And one of the things that we like to do, I don't know if this is going to work for me here. Like to look at, it's not working. One of the things we like to do is what happens to products when they get wet. So if this video was working here, we would gladly show you that, you know, this in a rain screen application, when this product gets wet, it basically holds onto the water. These products are often marketed and sold as in lieu of potting soil. Hey, that's great if you want to grow a plant or a tree or a shrub or a garden. But when I have this product in my wall cavity as insulation, I don't want it to hold all that water. And the reason is that totally changes and reduces my R value. And so that makes us think, how often will that insulation get wet? Well, if it's behind brick is a rain screen. It's designed to get wet. Is it a true rain screen application where it's going to get wet? If it gets wet, how long does it take to dry? What is my effective R value during that time? If I'm in Seattle or if I'm in the Carolinas during the rainy, cold season, and that insulation gets wet, what's my effective R value over the next 2 months, because it's going to take X amount of time to truly dry out? And what is the air moving in my cavity due to the effective R value? And just another point here, and I'm going to try to speed things up, just so how important it is that we make sure that our wall cavity is precise. This slide, basically, a consultant went to Disney and did a study on how much water could potentially get in the building if we didn't properly account for a control layer and thermal performance. So basically, they measured a 3/4 inch hole. It's equivalent of a 16th inch crack 1 foot long. Our control area was 500 square foot wall. And what they found is that they captured 80 ounces per day of water that came through that very, very, very small hole. Over a year, that's 228 gallons of water. So that's why it's so important that we get this done right in the field, because, you know, is that building equipped to take all that water out of the air once it gets into the building? If not, most of them aren't going to be. If not, what does that water do in that wall cavity or inside the building? Does it lead to structural degradation? Does it lead to mold? Does it lead to mildew, rot? Something to think about. So again, in our wall cavity, when we know we're going to get water, how is the insulation going to perform when we have wind moving through it? It's going to lower the R value. So again, we have an insulation product that we know we're going to have wind moving through that cavity. What's our effective R value? With fibrous insulations, it's going to be lower. So based on building science, I think there's pointing out there's different options, but you know, think of the other factors that make you decide really what is the right solution. And so I'm going to quickly go over some real world examples of ISO. There's a building science expert, Stephen Doggett, that did a study, and he basically looked at different markets across America, and they're all in the different climate zones. And he basically took two wall assemblies. The first one is a heavy duty coated fiberglass facer over ISO. And then the bottom one is our composite product, which has a piece of plywood or fire treated plywood bonded to the ISO. And he looked at this throughout the country, and he looked at the different climate zones and adjusted the R value based on what that zone mandates. Here in Alaska, it's going to be higher. In the South, it's going to be a little less. And that's what our assembly looks like from the inside to outside. That's what it looks like with the composite product, and I'm going to show you what an advantage that product is here in a second. He put his WRB on the outside. Again, that product allows you to use not just brick, but any type of exterior cladding or veneer. And then in his summary, he basically said that these two types of assemblies work at any climate zone across America. And we can get you further information on that if needed. Now, we live in North Carolina, and in North Carolina, we're somewhat unique that we actually reflect 3 different zones. Half of North Carolina is zone 3. The other half is zone 4. And then as you can see, the green area up in the mountains, there's about 5 counties that actually follow zone 5. So talking more specifically now about ISO, just to reiterate, higher R value, thinner profile, the cost per R, ISO is going to be the most inexpensive in the marketplace. And then we're going to have much better fire performing properties than the other foam plastics. Remember that roofing example I shared with you? Again, just to reiterate the R value. And then the different assemblies. So this is real world. On the left, to meet R10, we're going to use 1.5" ISO. In the middle, that would be 2 inches of XPS. And then on the right, that would be 2 layers, 2.5 inches of mineral wool.
And Scott, this is Ryan. If you don't mind me interrupting real quick, I know we do have at least one question in here. I think we have a couple more, so let's take a quick pause and address these. First question was, when did code remove the allowance for Z-strip with continuous insulation?
If you read the building code, it specifically says the only things that could not basically stop insulation as being continuous for, this is for commercial applications, obviously, is again, service openings. So that would be a window, a door, a louver, a garage, or fasteners. So we've still used Z channels, but that does not technically meet the building code. That product would have to be a non-conductive material other than steel.
Okay, thanks for that one. We had a second question that I think is a little bit more broad, and this may have been from a couple slides back, but you know, this isn't being enforced, which I think we could sort of generally say continuous insulation, commercial applications in particular. It's not being enforced from a code side, so what are we to do? That's a pretty big question. There's a lot of ways to address that, I think, but maybe Scott, what are some of the ways that you all see in the field, you know, either working with code officials on enforcement, or what are some of the best practices to make sure it ends up happening and that enforcement is actually happening?
Yeah, so, you know, as I mentioned, things have changed the last 10, 12 years. You're right, it's not always being enforced, but as a applicator, it would be scary, right? I would give my designer or my general contractor, I would give them fair warning to say, hey, this is what the code says, just so you know. I'll do what you say, but this does not technically meet the building code. I would do that to protect myself, because heaven forbid you got, you know, right before the project started and the red flag went up, then from a cost standpoint, you could be way in trouble. I would definitely do the right thing by getting educated, and two, I would communicate that to my customer and share that with them. And again, that's a pretty open-ended question.
Sure. Okay, thanks, Scott. I think that's it for now, so we'll let you go ahead.
Cool. So I'm going to take the last probably 4 or 5 minutes here, just talk about some of the Hunter products, and there's a handful of different products and how those actually get used. So the most common one would be XCI Foil, and I'm a visual person, so I love these slides and see exactly how or why this gets used. Here in this slide, we've got some fiberglass insulation, the metal studs. We're trying to show that we can put a gyp board right on the studs, or we can actually put an air barrier over top of the foil. You can do it a couple different ways, and then our brick ties are installed in between the sheets. But this would be just a regular foil-faced product that was typically used in this type of application. Can also have cast stone over mesh, as you see on the left, or it can be used with stucco on the right. You can use metal panels, whether it be siding, ACM panels, plate. You know, that product can be used in almost any application. It meets the code and NFPA 285 requirements in hundreds, if not thousands, of applications. And then over on the right, too, natural stone. I think the key things that we want to pay attention to in these type of applications are: where's the control air, where's the air barrier, are we penetrating that when we attach our racking system, or we attach our veneer, and if so, you know, is that hole getting patched? That's just absolutely critical. We've got some horrible examples of when that doesn't happen, what actually happens to the building when we try to hit that stud all the way in the back and we miss it, move that fastener, now we've created a hole. You can attach those products directly to the stud and tape the joints, and then that's your control layer. Lots of different options here, and they all impact cost. And then a Class A product that would have a little bit more higher fire properties within the board, and those same options when it comes to air barrier and applications of veneer are all available. So that's the foil faced. The product that we really like is this coated glass mat product. The foil can often get punctured by other trades because they're just not paying attention to it. But with the coated glass mat, it is super tough, it's super rigid, and it can kind of almost hold up to anything. And then another product that we use is a Armatherm Z-girt that is a non-conductive material that could be used in this application, just like this that gray material is highlighting. And again, same options for CG, fiber cement board, stone. And then another product is called 286. This often gets used on the inside of a big concrete tilt-up panel or a pre-engineered metal building. It's got a foil facer on one side and then a really pretty white facer on the other side with the white tape so that you can leave that exposed and it looks nice. And then the product that is most popular is going to be our XCI Ply and or a product called NB. The only difference between those two products is the Ply is made with fire-treated plywood. So if we have to meet that NFPA 285 requirement, we would obviously need to use that. If we don't have to meet that requirement, we could use a non-fire treated piece of plywood, whether it's 3/4 inch, 5/8, 1/2 inch. And the huge advantage with these products is that we could put our air barrier on the outside. Remember that study that we showed you from Stephen Doggett? And now the beauty is all of this, the load for either the panel or the brick is carried in the face of that, that ply or MB. So we're no longer screwing through our control layer blind back to the stud. All the load is carried right there. You can put any type of veneer. So you can do natural stone, stucco. We have a job along the coast that's using slate panels, very heavy, high wind zone, and they're using this exact assembly you're showing here. And then the MB could be used with wood construction and actually provides that racking structural support that's needed as well. So these products are growing. Expect to see more of those. It's going to be more cost per square foot, but the overall assembly is going to be much less. And we're taking all that risk away from the contractor to make a big mistake. So Hunter is just a great company to work with, great marketing, technical support, great products. Actually have an app to help you meet your building code, your NFPA 285. Lots of social media, great technical support. So with that, Ryan, I know we kind of ran a little bit long, but we're done.
Great. Well, thank you, Scott. We're got 3 more minutes, so I think that was definitely on time. I appreciate you doing that. Lots of information. And just so that folks know, we'll make sure that everybody gets a copy of this presentation as a PDF here soon after. You'll get that email and then also a link to the video recording. So just checking around in the chat box. I don't see any other questions or comments right now, so feel free to put those in if you'd like to. And in just a couple of minutes, we'll open up the phone line for folks that want to stay on and maybe have some discussion that have a little bit more time. So before I ask Scott to just kind of give it a little wrap up here and also see if there's any questions, just want to again thank folks for participating on the webinar today. If you are interested in seeing other video recordings, we have those on the NCBPA members only website. So our members have access to all of these types of recordings, no additional cost. So you can share those with your coworkers and some of the folks that you work with if you're interested. And membership is available on our website, of course, buildingnc.org. Want to thank Scott for the plug at the beginning. There's quite a lot of work that we're doing on code, on education, working with code officials and different types of developers and builders and contractors as well. And just a lot of work to do on this side of the industry to keep us growing in the right direction. We're committed to that and appreciate companies working with us and individuals. And again, if you want to consider a board opportunity, we definitely have that available. Scott's a former board member of ours, and I see a couple board members on as well right now on the webinar. So thanks everybody for your support. So Scott, I think we'll stick around here for a couple minutes and see if there's any questions or comments in the chat box, and then we can open up the line as well. Before we do that, any just kind of final questions, comments, or information from yourself?
Yeah. Again, I would highly recommend getting involved in NCBPA. It's a organization that actually making a difference. And I would encourage you to get involved, and then also pay attention to the upcoming conference this summer. I know we'll be there and be involved. And then as far as what we talked about here today, get educated. There's plenty of resources, and just reach out for help. Again, it's an evolution. Things are changing, but they're changing for the better. So feel free to reach out to help, and we'll do the best we can to support you. Thank you.
Great. Well, thank you, Scott, for those kind words. I do appreciate that. So we'll go ahead and open up the phone line to see if there's anybody that has questions. So if you're not already on mute, go ahead and put yourself on mute if you don't want to talk immediately. But the lines are open for folks that are still on. So if you do have a question, feel free to speak up or ask a comment, and we'll stay on the line here for a couple minutes and see what people have to say. So go ahead if you're interested.
Yeah, I cut up into little pieces and put it in the microwave.
Yeah, I tried that. Guess I can call him.
I can hear someone named Victor got himself open. Victor, do you have a question by chance? Okay. Yeah, muted Victor there. We've got some people have some feedback a little bit, so we'll just see if there's any other questions from other folks on the call. Okay. All right, I don't see any, so I think we're good for today. So Scott, thank you again for all that you do. We will make sure to get this information out to folks on email very soon. So check your inbox, share that with your coworkers. And if you have any additional questions, comments, or needs, please do get in touch with Scott or myself, and we'll make sure that everybody gets contact information out in the email as well. So thanks, everybody. Have a great day. Have a good rest of your week. And if there's anything we can do to help, let us know.
Thank you.